Okay, so here are some extra examples from the end of this section in our book. So the first one says, sketch the given whole numbers on a number line, then arrange them in order from smallest to largest. All right, so when we have a number line, the first thing we really have to do is we always have to go ahead and we have to mark it. And so we'll start with 0, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and that should be enough. And now what we're going to do is we're going to mark each of these points on the graph. And so at 2, we'll put a dot. Then at 8, we'll put a dot. Then at 0, we'll put a dot. And then 1, and then 3, and then 7, and then 4. And so that's the first thing. We drew the number line, we marked off the equal units, and then we put dots at each of these. And now then we're supposed to arrange them in order from smallest to largest. Remember, the smallest numbers are going to be on the left, the largest ones are going to be on the right on the number line. So we can just say, okay, well, ordering them from left to right, we get 0, 1, 2, oops, that comma looks kind of funny there. And then 3, then 4, and then we go 7, and then 8. And we could have done that. It could have said, okay, well, 0, 1, 2, 3, 4, 7, 8. But once we put it on the number line, we can just look at the dots and we can write it immediately, just directly, and not have to worry about anything. All right, the next one says create a number line again and to determine which of the two given statements is true. So the first one says, is 44 less than 80 or is 44 greater than 80? Well, what I'm going to do is I'm going to only put 3 dots. I'm going to put 0 for our starting point. And then as I move across, well, next one I'm going to, if I'm counting up, 44 is next. And if I keep counting, then 80 comes after here. And so then I have the point 44 and I have the point 80. Well, what is the true statement? Is 44 less than 80 or is 44 greater than 80? Well, 44 is to the left of 80, so 44 is less than 80, and so that would be our choice. Now, similarly, if we have 0, then we count up, the next number is going to be 65, and then we count up some more, and we have 83, okay? And 65 and 83 are two numbers. So is statement 65 less than 83, or is the statement 65 is greater than 83 true? Well, 65 is left of 83, so it has to be less than 83. And again, the first one happens to be the true statement. All right, so the next one we have some large numbers, and it's asking us what digit is in a specific place. So on number 3, it says what digit is in the hundreds column. Well, so we look at our numbers, and in the hundreds, well, we have ones, tens, and hundreds. And so what digit's there? A 0. Okay. The next one says what digit is in a hundred thousands? Well, hundred thousands, that's the next one over, and it's going to be the third place. And so that's going to be a 4. The next one says, which one's in the millions? Well, that's going to be 2 skips from here. So it's going to be 1, 2 skips. That's the millions set. And it's in the single millions. And so it's going to be the first one here. And so it's going to be a 5. And then the next one says in the 100 millions. So we know it's in the third group. So it's 1, 2, 3. And 100 millions is going to be the third one. So it's going to be a 6. Okay. And so again, you just have to know how the units go. So it goes into the ones, thousands, the millions, and then the billions, okay? And then you just have to know as you go, it goes the zeros or the thousands or the, it depends on which one you have. If this one is going to be the ones, that's thousands, that's millions, that's billions, and then it goes tens, 10,000s, 10 millions, 10 billions, and then hundreds, 100 million or 100,000s, 100 millions, and then 100 billions. And so it follows the same kind of pattern across. You just have to know which section you're in to know where you're at. All right, so now this one's talking about rounding. So this one says to the nearest thousand. So where's the thousand? So the thousand is right here. So that's going to be our rounding digit. And this is going to be our test digit. Well, 8 is greater than or equal to 5. So that means we're going to move that one up to a 7 because it says add 1 to it. So that's going to become 5, 7. And then drop everything else and make it a 0. Okay. And so that's all we do. Now the nearest 10. And again, all you have to know is where these numbers are and then just do what we just did. So this is going to be our rounding digit and this is our test digit. Well, our test digit 5 is greater than or equal to 5. And so that means we're going to go up 1. And so that's going to become a 7. So then we're going to have, okay, that becomes, hello. There we go. That's going to become 2, 4, 9, 7. Everything else becomes a 0, and so that's a 0. Now this one's to the nearest 100. Well, the 100 is right here, so that's going to be our rounding digit. That's going to be our test digit. Now the question is 4 greater than or equal to 5? No, it's less than. And so that's no, so that means we're not going to round that rounding digit up, so that's going to stay 9, 3, 1, and then we're going to drop all the rest to make them zeros. Okay. So when we don't round it up, we keep that same number there, the 1, and make everything else zeros. Now this one, to the nearest 100,000. Okay, well, where's that at? Well, that would be actually out in front here. So that's going to be our rounding digit. Right now, there's nothing there. And so we look here, and our test digit is 4. So again, is 4 greater than or equal to 5? No. And so we keep that digit the same, which is a 0, really, because there's nothing there. And we make zeros for the rest of the way. And so when you make all those zeros, 0, 0, 0, comma 0, 0, 0, well, that's just 0. So when you round this to the nearest 100,000, we end up with 0. Okay, and that makes sense because this is less than 50,000, and so if there's less than 50,000, that's not going to round up to 100,000, and so then we have to round down, which gives us a 0. Now, some word kind of problems to give you similar kind of thing to do. You still have to round, or you have to read a graph, but it's in a word format. So here it says, according to the U.S. Census, the population of California is 36,756,666 as of July 2008, and we want to round to the nearest 100,000. So where's the 100,000? Well, that's going to be right here. So that's going to be our rounding digit, and this is going to be our test digit. Well, 5 is greater than or equal to 5. That's true, and so that means we're going to round this one up one more. We're going to add one more to it, so that's going to give us 36, and 7 plus 1 is going to give us 8, and then we're going to have all the rest of them be zeros. So it's going to be roughly 36,800,000 when we've rounded it to the nearest 100,000. And when you look at it, when you get done, it should be, when you read it, it should be 800,000. Or if we had over here, this one too. Well, that one doesn't make sense, but to the nearest 100. 93,100. So the last time you say a number is going to be kind of where you've rounded it to. All right, so the following bar chart shows the average weekly NASDAQ index for 5 consecutive weeks in 2009, beginning with week starting February 1st and ending with the week starting March 1st. What was the average NASDAQ index for the week starting February 8th? Well, we have to read where the weeks are. So here's February 1st, February 8th. So that's the week we want, then 15, 22, and 1. So we could have done any of the weeks. And now what we're supposed to do is what was the average? So now we have to look at the average. Well, that means we look at this bar. And so that bar is all the way across here. Now, if I split that up, I'm going to guess that's around 1540. I don't know exactly because reading numbers between this, it's going to be close. So I'm going to say it's approximately 1540 was actually the NASDAQ index, okay? And again, this is where we can use that approximately equal to. It's not exactly equal to because we can't really tell, but it's going to be approximately 1540. Maybe it's 1545 or 7 or 1537, you know, but it's in that vicinity anyway. All right, so this one says the 5 cities with the largest number of reported violent crimes in the year 2007 are reported in the following table. Create a bar chart. So we need to create a chart that looks like this one. For this data set with 1 bar for each city. All right, so what we're going to do is we're going to make our graph kind of first. And so what we need to do is think about what we want to do for our thing. So we'll have, I don't know, we go from here 16, 17, 18, 19, 20, 21, 2, 3. If we make 7 marks, 1, 2, 3, 4, 5, 6, 7. Maybe we can make this one 1600, then 1700, 1800, 1900, 2000, 2100, 2200, and 2300. Okay, and again, this isn't going to be precise, hand-drawn. It's not, usually doesn't look good. You want to do it like in Excel or something if they wanted a pretty nice graph and make it exact. All right, so we're going to have Detroit. We're going to have St. Louis. We'll have Memphis, Oakland, and we'll go a little bit further and we'll have Baltimore. Okay, so we want 2289 for Detroit. Well, 2289, that's going to give us a bar. Doesn't go up to 2300, but gets really close. And that would be our bar. And I'm not going to color them in, I'll just make the bar itself. Now, St. Louis is almost 2200. So we go up here and then get almost to 2200 and then come across. Memphis is 1951, so it's almost 2000. So somewhere in that vicinity. Oakland, 1918, so it's just over 1900. And then Baltimore, 1631. So it's a pretty small graph. It kind of maybe something like that. Okay, and again, hand drawn, these aren't going to look good, but the key things is we keep a space between our bars. We label what's on the x-axis, you know, our Detroit, and then our y-axis, this is going to be violent crimes, and then we just make our numbering system here, and then it looks, you know, approximately equal to what we have from our table. And again, if we were trying to go from this to our table, we're not going to get exactly 2289 off of this graph. We're going to say, well, maybe that's 2280 or 2290 or something, and this one's going to be like almost 2200, so maybe 2295 or something. So we're not going to be exact, but that's kind of to give you an idea that we can go back and forth from the graph to the bar graph in this case. Now this one wants us to read off the line graph. So we have a team of students separated a small bowl of M&Ms into 5 piles by color. The following line plot indicates the number of M&Ms of each color, how many red and how many green M&Ms are in the bowl. Well, we want red and we want green. Well, we just go to the graph and look for red. Well, here's red, and it says the number of M&Ms is on this chart, so we say red is 3. Now green, well, we go to the bottom and look for green, and then we go up here, and then go across and see that's 9. So there's 9 of the green. Well, we could also go and say, oh, how many blue are there? Well, there's 2 blue, and 3 yellow, and 3 brown. So we could get all the numbers, but they only ask for those 2. And again, it's just looking at whatever color we needed and then following the dot off to the left to see how many there were of each color. Now this time they want us to actually draw the graph, and they want a line plot, it looks like. So we've done all the separating into colors again, and now we want to draw the line graph. So Let's say we have red, and then green, and then blue, and then yellow, and then brown. And then we start here and we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9's the highest, so that's as far as I'm going to go. And that's going to be number of M&Ms. Okay. So red had 5. And so this is going to be a line graph. So we'll just go up to 5 and make a dot. Then we go to green, that's 9. So up here we'll have a dot on green. And then blue is 7. So we'll go over here roughly there for 7. Yellow is 2. So it's roughly there. And brown is 3. So it's a little higher. And so now we just draw And again, drawing straight lines on the computer is not the easiest. And so that would be some kind of a line graph. Again, it's not straight, not perfect, but that's what would line graph would be, taking our numbers from here. And this one's going to be a little easier because we know that's 5, that's a 9, that's a 7, that's 2, and that one is 3. So it'd be easy to read the smaller numbers like this off the uh, vertical axis rather than the one previously where we had, huge numbers and we had to try to figure out where that was in there. So that's not as nice. All right, so that's all the examples I have. Hopefully that will help you with the homework.